So what we are looking at today is when you are solving an equation with logarithms or exponential equations. So when you look at this, there are going to be three different strategies that we're going to look at for solving exponential and logarithmic equations. So your very first strategy is to rewrite the original equation in a form that allows the use of the one-to-one properties of exponential or logarithmic functions. Some of us will read that and say, what are you saying? So let's look at an example. So the first thing is for part A is to recognize that you can rewrite 32 as a 2 to an exponent. So what I mean by that is 32 is 2 to the 5th power. So you can rewrite 32 to have a matching base. And so now it's fairly straightforward that you have to have your exponents match in order for you to have an equivalent statement. So therefore, x equals 5. For part B, again, what you're going to look at here is we can go ahead and since this is equal to 0, I can move this part over. And so when I have that, I've got log base 4 of x equals log base 4 of 8. And since our bases match, again, that's that one-to-one component. Since our bases match, in order for the equation to be equivalent, we have to have x equals 8, and you are done. If you look at part C, C is very similar. We can write both of these as a base of 3. So 1/3 is going to be 3 to the negative 1 power, and then 3 is 3 squared. Now remember, when you have a power to a power, you are multiplying these. So you can go ahead and multiply your negative 1x, and you're going to set that equal to 2. And so therefore, when you solve this, you get x equals negative 2. So again, that's when you can have either a matching base in your logarithm or a matching base with your exponent. Your second set of examples is when you are rewriting an exponential equation in logarithmic form. So first off, what you're going to do is you're going to ask, what is the inverse? In other words, how am I going to undo my exponential to get that x out of the exponent? So the way that you're thinking about this is since that's a base e, to get rid of that, you are going to do the natural log. Oops, excuse me, I accidentally touched that. So you're going to do the natural log of e to the x, and since you did the natural log to the left side, you have to do the natural log to the right side. What that's in turn going to do is that's going to cancel that base of e. And so when you look at this, you are now going to have x equals the natural log of 7, and you just type that in your calculator, and you get approximately 1.946. And that's it. So basically you are undoing, and you're doing your inverse function to be able to cancel out and release that variable from your exponent. Okay, so let's look at the next one. So we can move this over. So we have 5 equals e to the x. Again, to cancel out that e base, we have to do the natural log of each side. That's going to cancel out that base of e. So you have natural log of 5 equals x. And now if you were to type that in our calculator, x is approximately 1.61 for our value. For part C, it's the similar idea, except you don't have a base e. You have a base of 0.98. So this gets a little ugly. You're still going to do the log on each side, but you're going to do log of 0.98. That's going to be your base. So log base 0.98 of 0.98 to the x, and since you did log base 0.98 to the left, you're going to do the same thing to the right. Okay, so it looks a little ugly. Again, what that does on the left-hand side is that cancels out everything but your x, and now you have to evaluate what is log of 0.9 or log base 0.98 of 1.6. And so what you can do there is now you can apply your change of base theorem. And so we can go ahead and in our calculator, we would type log of 1.6 divided by, since your 0.98 is in the base, that is where your 0.98 is going, is in the bottom of that fraction. And so when you type that in your calculator, you would get a value of negative 23.264 for your value of that logarithm, okay? Moving on to the third option. To rewrite a logarithmic equation in exponential form and apply the inverse property. Now here's the thing. It's basically the same idea as what we just did, except for instead of starting an exponential and going to logarithmic, you are starting in logarithmic and you're moving to exponential. So don't forget, natural log, this is the equivalent of log base e of x. So basically, your inverse is e to the x. Okay, so in other words, another way to think of this is I could rewrite this by sliding this around and making this e to the negative third equals x. And then I could just type that in, or I can leave it as a fraction. Since it's a negative exponent, that goes to the bottom, and I can do 1 over e to the third. Okay, same thing here. I can go ahead and just multiply this around, or excuse me, not multiply. You can rewrite that by sliding that under the negative 1. So 10 to the negative 1 equals x. And so again, we have a negative exponent, so it's going to be 1/10 equals your x. Last but not least, same idea. Slide that 3 underneath. 3 to the 4th equals x. So my x value is 81. Okay? So you have several different options. Now, you're going to have a chance to practice this today. You are also going to have an opportunity for more practice if you feel like you need some more examples. Okay, the only way to get better at these is to practice them and ask questions. One final thing I want to introduce to you today before I finish the video for today, we're going to split 3-5 into 2 different videos, is what's called the order of magnitude. The order of magnitude is just the difference of powers of 10. So for example, what I have here is a screenshot, and if you look, this is 10 to the first power. This one is 10 to the third power. So if you look, the bottom number to the right is 2 orders of magnitude greater than the first. So in other words, if you look, we look at our exponents, that 3 minus 1 is where that 2 orders comes from. So again, all you're looking at is the power of 10, and you're doing the difference of that. That is your order of magnitude. So again, this is just kind of an intro into 3-5. We're going to spend some time tomorrow looking at some specific examples, some models with this. So please, if you have any questions, don't hesitate to ask. I am going to give you guys an opportunity for more practice with solving. So if you need it, just please ask if you have any questions. Thanks.